Welcome, everyone, to our systematic review and meta-analysis online seminar series. I'm James Pliszewski. I'm the chair of our AERA SIG. It was nice to see a bunch of you at in person at AERA last week. I've seen social media posts about bugs going around from post-conference, so I hope everyone is feeling well still. Today, I'm really pleased that we're joined by Dr. Matt Grainger. Matt holds a PhD in zoology from University of Pretoria in South Africa. He currently works as a researcher at the Norwegian Institute for Nature Research in Trondheim, Norway. His expertise is in environmental evidence synthesis and decision modeling. And today he's going to be sharing his some work and his experiences with the ESHackathon. I'll leave it to him to explain what that is. And our ground rules for today will be just as usual. Please feel free to leave questions or sidebar comments in the chat during the presentation. We'll monitor the chat and interrupt if there's anything that's really burning. And then there will be time for Q&A and discussion after the presentation. With that, I will pass it over to Dr. Matt Grainger.
Thanks, James. Hello, everyone. I can't really see any of you, but hello. Yeah, so I'm going to talk to you about the ESHackathon and some of the things we're doing, and I'll demonstrate some of the tools we've got towards the end of the talk. But I'll give you a bit of a background of where we come from. So I'm talking with three different hats on. So as James said, Norwegian Institute of Nature, so it's in Norwegian there. Also with Collaboration for Environmental Evidence, where I'm a board member, and Evidence Synthesis Hackathon. And working with these three different organizations and being a part of three of them is sort of beginning to become a synergy, but it's taken quite a while to get there. So what is the ESHackathon? Oh, my light's gone off. What is the ESHackathon? So the ESHackathon is basically a community practice of people who are interested in evidence synthesis, but also interested in open source technology, code, to bring people together to make some tools that help practitioners do systematic reviews, meta-analysis, systematic mapping approaches. ESHackathon is the Evidence Synthesis Hackathon. It's not very original, but that's where the name comes from. And we've been going since about 2018, 2019 as a entity, a group of people. So these two guys in the pictures here, Neal Haddaway, in the sort of dark background, Martin Westgate, started the hackathon in 2018, and it was really was about having an open software development event. So the idea was a single event, but that soon developed to several other events. And we've evolved since then to sort of conferences, the ESMA Conf, so Evidence Synthesis in R conference, training courses, and more hackathons. So Neal is still very much involved with the hackathon, and he's driving things forward a lot of the time. Martin's had to step back a little bit, so I've taken over his role to try and promote the hackathon and get things moving, really. So why did we start ESHackathon, and what was the thinking behind that? Well, systematic reviewing evidence synthesis is increasingly massively and across all different disciplines. But even though there's lots of tools available to help you in systematic reviewing, they're often paywalled, or if they're not paywalled, they often don't have long-term support. So our packages often go redundant, and they might sort of just die a death one day. You not see them again. There's a lot of redundancy particularly in open code. So lots of packages do the same thing in probably the same ways, but it's good to maybe try and reduce that redundancy down a bit. The big one for us is there's very limited interoperability. So the outputs from systematically reviewing software can't be used in another tool. So that's something that's a pretty big barrier. So you may have experienced yourself where you're working through on one tool, and then you have to export in a certain format, and it all gets a bit messy. And finally, tools are not validated often, so or they're validated by the developers alone. So they tell you their tool works really, really well, but then you try it, it doesn't work well for your circumstances. And these are all the sort of things we wanted to avoid by having a more open and transparent approach to making tools. So back in 2018, there was the principles, the Vienna principles, by a group of people who are the collaboration for automation of systematic reviews. And I put this in here because I think they're pretty good pretty good principles for us to follow. So the ability to work with different tools at different stages of a review is really important. So this is making sure that you can use different tools at different points. You're not stuck into one tool that doesn't do everything you want it to do. As I already mentioned, tools should be interoperable, so data from one tool should be able to move to another tool without very smoothly and easily. There should be collaboration to cover all the different stages of synthesis, so different people, different approaches should be looked at. Code should be open source. That means it's available to everyone, and also people can adapt it to their own circumstances. And there needs to be some sort of standardization and validation. So these are the sort of things we're looking to try and keep in mind when we work with our hackathon tools, and we make some tools that we like. So the hackathons themselves are small groups of people, usually 10, 15, 20 people maybe. And before COVID, we started off in Stockholm, which is on the left-hand side here with the tower. Before COVID, this 2019, we started, and it was bringing together people who have an interest in systematic reviews or evidence synthesis in general. People have an interest in coding, in R mainly. The reason we started with R, it's not really that we're wedded to R, it's just that we were all researchers who worked in the environmental field, and that's often R is the area, but it's open source and it's quite adaptable to different approaches. So we've pretty much stuck to R, but we have other tools that are worked in other languages, so we're not against that. Yeah, so the hackathons pretty much getting a group of people together. We have a few loose ideas that could be projects, which I'll give you some examples of, or it could be a paper, a discussion, and basically trying to hash out some of these things. And within 3 days, it's really amazing how much work you can actually get done. It's actually quite frightening when you consider how much work you can get done in 3 days when you go back to the office and it's 6 months until you get something else done. So they're very intensive periods of time working collaboratively. So Stockholm was the first one. Canberra, which is this one with a very long alleyway there, was the next one. And then we had COVID, so we had to do some online hackathons, which were different. It's quite good to get the personal collaboration going sometimes, but we still continue on to develop projects using online collaboration, which is good. Last year we had our next hackathon, which was at Newcastle, so close to where I'm from in the UK. We had, I think, about 30 people at the hackathon there, and we've just found out that next year, well, sorry, this year in December, we'll be having a hackathon in Newcastle again. So it's if anyone's going to be in the UK at that time, please come and join us. So we're really open for new hackathons. Neal or I don't have to be there. It can be something that we can participate remotely. But if you have any ideas or any project ideas, just suggest them to us. After the hackathons, we started to develop an idea of a need for a conference. And so in 2021, we started with the ESMAconf. We've run 2 of these. This year, unfortunately, we can't run it. Neal and I have sort of run out of time in our day-to-day jobs. So we're a bit sad that we can't do this, but next year we're going to have a bigger ESMO conf. What's been really good about this is that it's fully open, fully free, and available on YouTube. So you can go back and you can look on the YouTube channel and you can find all the talks and all the presentations, all the discussions. And a lot of them are tutorial type talks. So people going through their own tools, how they develop those tools and how to use those tools. So it's a really good thing. And amazingly, we're having a lot more views after the event than those during the time. So we see it more of a sort of a training resource or a learning resource that people can use over time. So it's been quite successful. Increasingly, we're doing training. So this is the only thing we really charge for. We sort of ask money for, and that's to cover Neal's time because he's doing most of the training. So it's training about systematic reviews, systematic maps, and some of the methods behind that. And it's online, different lengths, but 1 or 2 days of training. It's been fairly successful. So we started this year, and it's the one way we actually sort of make some money to run all the stuff behind ESHackathon. So yeah, it's have a look on our events page if you're interested. So the interesting bit is our tools. So we're developing lots of different tools. Some are close to being finished, some are finished, I would say, whereas some are very at the early stages. And I'll give you some examples of different tools that are close to finished, and also maybe one that's still being developed. Just give you a few ideas of what sort of things we're doing. So, for example, Metaphor Reports is a tool that Wolfgang's been developing, where using Metaphor, it actually just gives you a standardized reporting in R Markdown, Quarto nowadays, of your meta-analysis results. So it's a way to standardize what is reported and also make it easier for people. And other tools we have are things to, like Big Fix is fixing bibliographic files, so bib files, RIS files, for example. Predictor is a tool to predict the time it takes to do a review. That's one we've been working on quite a lot these last few months, because the tool itself was developed by Neal and Martin, but designed for environmental studies. But now people are trying to use it for medical, health studies, other disciplines. So we are trying to sort of update the tool. So we'll have Predictor part 2 that basically uses a whole host of different studies, so you can choose which subject area you're in. 2 tools that aren't really working that well at the moment are the Google Scholar Scraper, GScraper, and the Grey Lit Searcher. So these are things we need to go back and adapt, because Google Scholar changes the way the API works quite often. So it's these 2 tools were a way of sort of getting behind Google Scholar and extracting your search results. But yeah, neither of them work that well at the moment. So those 2 need some work. So I'll give you some examples of some of the tools. The first one is citationchaser. So citationchaser is our most popular tool. It's one of our most highest cited papers we have. And if I just change this, will you still see it? Okay. So can you see the citationchaser tool? It's just uploading. Yeah, great. Okay, so this tool is a way of doing forward and backward citation chasing. What we've got is it's a very it uses lens.org underneath, and allows you to start with a group of articles using one of these identifiers. I'm just going to give you an example here. Oh, hang on. Sure that I've copied the right thing. There we go. So that's a DOI for a paper. You can see we've got all these different ways of doing. We're starting to develop this now with some title matching as well. So that's something which will come out soon. So if we load our input articles, so if you have many articles, just do it with a comma separating them. Load your article. So it says it's found the article, which is great. And this is the article it's found. Is the article about citation chaser. Then what you can do is you can find all the references from that are indexed on Lens. This takes a few seconds. So you've got all the list of references that are found on Lens. And then you can download a RAS file, a RIS file. And the RIS file is the format we're thinking of sort of using to link our tools together. So there's some development going on there, but we're thinking that's probably the best way to do it. We're welcome to other, open to other ideas though. So you've got the papers that our paper cites, but then we can also find the paper that papers that cite our paper. So we look on the citations, and then it searches on lens.org and gives you all the papers that cite this paper. Okay, and it just gives you a table of those. And again, you can just download a RIS file of that. And so this is really good for citation chasing, so supplementary searching for papers. It gives you all the papers you might be interested in. There's two tabs that aren't working at the moment. This analysis tab, which was sort of looking at co-citation and how the articles are related to each other. That will come back in a few weeks' time once I've fixed it. So there's a few developments there. And also this network tab is also just a way of visualizing the relationships between these. This is my baby and I loved it very much, but it was useless because it was just like a massive blob of papers everywhere and how they're linked together in a graph. And I love graph theory, but it doesn't really work for visualization. So I have to go back to the drawing board with that one and think how it can work. So that's the citation chaser. Please have a play around with it. And if you have any comments and things, you can look on our GitHub and have an issue there. If you've got any ideas, you want to add things to it, just let us know, or pull request if you want to. So the other tools we have, EviAtlas. So EviAtlas was from the Stockholm hackathon. And it's a tool to basically allow you to show and share systematic map data. So the landing page is this with some idea of what systematic maps are, how to use the atlas, how to cite it. We've got some sample data here. When you upload your data, it gives you a list of what the attributes are, just to make sure that you're uploading the right thing. And then you get, go here first, the database. So this is just the database that you have of your papers from your systematic map. You could do this for a systematic review if you wanted to, but and then for geographical locating of papers, for example, we've got this geographical evidence atlas. Here you can change the base map. For example, you can cluster points. There's one in Trondheim there. You can add a link, and if you click on a paper, it will link to that paper to the Google Scholar. So there's all kinds of things you can do. You can color the points by year. That. And you're able to save the map either as an interactive map, HTML, or you can host it yourself onto your own GitHub pages, is one way we describe it. Other things we have are descriptive plots. There's not much, these are not used much, but they can be useful. So for example, we can look at some elements of the database. So this is for the year, and how many papers were in each, how many studies in each year. Study design, the frequency of that. We have a heat map, and again, we can look at things like when the most evidence is for different types of study design, different periods, different nations we could do. So there's all kinds of things we can look at there. Neal's done a sort of tutorial walkthrough of how to use EviAtlas, but also how to save that for your own web page and how to publish it. So it's a very simple. It's actually very simple thing to do. There's some case studies people have used the tool, and this needs updating, but some of the reviews that people have actually used our tool, and you can see what they've done. So that's EviAtlas. This one. Another very popular tool is the Prisma flow diagram tool. So this is, as it says on the tin, is basically a way to develop a Prisma flow diagram interactively. So if you change these aspects on this menu here, it will change and update your flow diagram. That's probably a bit crazy having 100 databases, but let's do that. And you should see some numbers changing on this side here. You can download that as a PDF, a PNG, SVG, interactive HTML. So with tooltips, so people can look and see what these different things mean. And yeah, so it's a very versatile tool for giving you what most papers, most articles, journals is what I'm looking for. Most journals ask for now is a Prisma flow diagram. We have a similar thing for the roses form, which is an environmental version of Prisma flow diagram. So the final one I will show you very quickly, because I think I'm running low on time, is a new tool that's being developed mainly by Trevor Riley, and it's called CiteSource. So this is really at a very sort of early stage development, and the idea is to provide people the ability to explore a bit about the sources they use and how they relate to each other, looking at overlapping within different sources. And I shall show you some code here. I'm going to help you across. So make this a little bigger. Hopefully you can see that. Okay. So basically we can download the package from our GitHub here. And as I say, it's still in development, so I wouldn't do this for a few weeks because it's still getting changed. There's a few bugs in there. So if you have, for example, some citation files, in this case it's RIS files of all your different searches, and let's say you have some benchmark articles that you want to look, so and see where your benchmarks fit within your searches, and do your benchmarks turn up in the searches. You could load your citation files. So that's just a list of the files in a folder. So all our different searches and our benchmark there. And then you have this metadata file. So that's a list of the sources and the labels. So here the sources of the labels are the same. We've got the benchmark and then each search here, and then they're just labeled benchmark or search. And then you can read the citations. It takes a little while to come, so I've just done I've cheated a bit and made one ready before. But normally you just run this read citation, and it reads in the citations into a readable data frame format. Then we can do some duplication. So this is based on as much as possible the records. We've got titles, authors, and so on. All that information. It tries to run and tries to deduplicate the data. It does take a little while to run, so you have to maybe 5 or 10 minutes for this data set. But so I've again cheated. So the unique citations, dedupe citations, just looks for the unique citations in the list, and then we'll count them. And we can see here the data frame, all the unique citations, and it keeps the record IDs. So you can see that these are duplicated here. So those in different searches have been duplicated. This is one document. that's been duplicated across the different searches. So it keeps the records back, so you can go back and check and do some manual checking to see whether it is duplicated. We think it's pretty good though. And then we can do some looking at the different sources. We just do these. Yeah. So we have a nice little table here showing how many records are imported, 55 benchmarks, and how many of those distinct, 55. Search 1 at 978. So most of those, there is some duplication, yep. So just making sure there was, but looks like a little bit of a bug there because some of them should be smaller than that. So there are some bugs to be ironed out. And then what we can do is plot an upset plot. And what these plots show you is how much overlap there is between the different sources. So you can see here that there's, let me see, benchmarks. If you count up these individual dots here, that's going to be 55 across there. And you can see that 9 benchmarks were found in all searches. I hope that makes sense, how they're overlapping. Yeah. And then we can do a big table to show which searches had which benchmarks in. So we have here the benchmark, was it found in search 4, 5, 1, 6, 2, 3. So this one wasn't found in any of those searches, but it was found in benchmarks, and so on. It just gives you a tick where it's been found. This one was found in 3 places, so on. And you can also get all the information from that paper and link to it here. So yeah, as I say, that's the tool that's really being developed quite rapidly, and this will be not just our code, but also be a Shiny app to make it a lot easier for people to use. So that's one of the things we really try and do, is make sure that our tools can be used not only by coders who have some experience with R, but also people just using Shiny app, so interacting with it using the web. So there are some obvious issues with that. So in low middle income countries, sometimes the internet is not particularly great. Even where I live in Trondheim, sometimes the internet is not very good. So we have to sort of come up with some solutions to help people use the tools when their internet is down, and that can be achieved mainly through R if they have R installed on the computer. But we need to make it a bit more user friendly of the way to do that. So I think that's probably all I have to say, but I can talk a bit more about these different tools if you'd like. I'll just go back to this last section. Let's begin. So I just want to say how to get involved with the ESHackathon. And please do get involved. We're really, really open. We want people to get involved. Yeah, the easiest way is propose coding or discussion projects. So if you have an idea, you think, I wish someone would make a tool to do this, we can make that tool, but we might not know exactly everything about it. So to come and talk to us and tell us what you need and how we could improve it. Use our tools and test our tools. Try and break them. Please try and break our tools. Do some funny things and some edge cases to see if the whole thing falls to pieces. It's quite soul destroying when you think you've made a really good tool and someone just comes and breaks it the first time. But it's useful for us to try and sort of make sure that the tools work for people. And you can leave an issue on our GitHub pages, or you can email us, whatever's easiest for you. Join us in a future hackathon. We'll put that on our website to say when hackathons are happening. So this one in Newcastle coming in December. But please apply to join us. If you're a funder and you have lots of money, co-host a hackathon. Invite us to come and to you, or we can do it online as well. You can fund an event. We really pride ourselves in making these as open as possible and trying to make it at least barriers to people who might not have funding or income. So if you can provide extra to help people join in, then that would be really, really good. So yeah, join our community. We're quite a big community now. We're growing all the time. These are some of the faces. I'm sure some of you will recognize some of the faces on here. Yeah, please join us. And if you've got any questions, just let me know. Thank you.
So much, Matt. We do have plenty of time for questions. There were a few in the chat that I'll let Mega look through.
Question from Ellie. For studies that cannot be found, I search manually, which can be time consuming. Any suggestions?
Yeah, quite a few different suggestions. Maybe we haven't got a specific tool that will help you with that, but we're developing a tool in probably the next year, I'd imagine, working with lens.org. So that's something that maybe we can think about how to sort of improve that. OpenAlex is a really useful open API for finding studies. And we're switching a lot of our tools over to OpenAlex now, which has more, it's not all the way there yet, but it has more ability to, for example, search on a title name or something like that with sort of this fuzzy matching. So even though you haven't got it quite right, it gives you a list of papers back that are close enough. So the citation chaser tool is using in this next iteration, which will come soon. We've got this title matching tool, and the user puts in the name, and if they don't get it quite right, but it's close enough, then it'll give you a list of possible papers that could be the ones you're interested in. So that's one thing of looking at. I don't know if that answers the question. But...
Yeah. Matt, could you talk a little bit more about the software development processes that you follow? Like I'm picking up on a couple of things here. One is like the pairing the Shiny apps with our packages, which I think is really useful. But yeah, I guess anything else about the development process and like working in a big collaborative group like this?
Yeah, so it's sometimes it's chaotic, but yeah. So we tend to try, and from the start, from the EviAtlas, we really wanted to start having a process where, if you're skilled in coding, you can adapt the tool to your own use. So that's why we have the R package there. But then having the Shiny app is our way of thinking. Is not fully open and not fully easy, but it's our way of thinking that to make it more open to other people who don't code. So that's our vision. So every tool will eventually have some form of more easy use app with it. For our collaborative coding, we use GitHub for collaboration, to discussions, issues, all in there. And it's been really, it's good fun to work with lots of different people. I've learned a load. I'm not a coder sort of by training or anything, but I've learned lots by just watching other people code. And at the first hackathon in Stockholm, it was really funny because we had academics and practitioners, and we sat around the table drinking our coffee and like talking about all the problems of systematic review and meta-analysis and how you do it and how you don't do it. And then we sat for maybe a couple of hours, and then the web developer guys and the coders had basically coded all the tools and made them perfectly for us, but we had to just fill in the bits. So it was really like it's an eye-opening process of different ways of working. So it's really good. We've got some really strong computer science background, people like Chris Pritchard, for example, who is a computer scientist who is now in paramedic studies, but he's got a lot of things to help us develop tools that are robust to things like our packages are always going redundant and dying off, extinction in packages. So Chris is helping us set up routines on GitHub that allow us to test if everything's working. So EviAtlas, for example, has there's actually two. There's a shadow version of EviAtlas. So when we do a development, Chris has set it up so we do a pull request and we can label it. And if it's a development, it goes to a different. So my personal view of the Shiny app, and that allows us to test if things work properly. Also, he's looking at Dockerizing some of the packages we work with to make sure that we have sort of that things don't go out of date and functions change. For example, we had one function that changed in EviAtlas that destroyed it for about 3 weeks, and I had to rewrite the function to make it work. So those sort of things we want to try and avoid. I hope that answers.
Those problems are a little bit familiar to me. I have a couple of packages that have a Shiny apps built into them, and have learned a lot, like the hard way, about developing that type of tool. So like you know, I guess one of my takeaways has been make all of the functionality in the package, so that the app, the interactive app, is really just like an interface to the package.
Yeah.
And I'm still struggling with trying to get let's see, the software development types would call this continuous integration, right? Like when you push a new update to the package, then the web app should get updated by itself too. Have you managed that?
Yeah, so not me, but Chris has done that with GitHub Actions. So he's got a couple of routines that you can actually probably steal from our both EviAtlas and the Prisma flow diagram GitHub, and that allows this continuous integration, and it's very impressive. I have no idea what it does. It's sort of dark magic, but yeah. If you just you can clone that file from I think it's in the GitHub folder in those on those repositories, and you can clone the file, and then you can use it, and you have to just change the where it's going to the output, and it's quite easy to do.
Are you hosting your own Shiny server?
So we have, yes. So we have a ESHackathon Shiny server.
Okay, so it's not through. Oh no, it looks like it is through Shiny apps.
It is through shinyapps.io. Yeah.
Oh, okay, I didn't realize it was possible to do to do continuous integration with Shiny apps. I'll have to take a look at that.
Yeah, and email Chris as well if you need help, because he's a wizard.
You've solved my problem for the day. You know, the other thing about software development, though, I guess, well, you mentioned like the you know, collaborating through GitHub. You know, Wolfgang and I have talked a lot about like the bus test, right? Like how many people need to get run over by a bus for the software to stop working. And it seems like this, you know, having a collective like this is one way to provide some there's a level of like robustness to the support of the tools. But so another thing that comes up in synthesis is like, you know, some syntheses are done with like even like a regulatory agency in mind. So they have like very stringent stringent requirements around software used for data analysis. Like you know, like FDA, right? Only allows certain software packages to be used. Is that on y'all's radar at all? Or is it these are more like tools for, you know, individual scholars or
yeah, so we're starting to think more in those terms, but that's something that Neal and I have spoke about this week, actually, is some of these things. Our main thing is really to have everything open as much as possible. And if people have individual you know, studies they want to keep separate, that's fine, but we want all our code and tool itself to be available to everyone. And sometimes we sort of run up against a bit of a problem with that. I think it's yeah, these tools are really designed for individual researchers and practitioners. But it's something we have started to think about as particularly working, for example, with lens.org, and helping them to develop tools they want to do, but they really want things to be open as well. So it's sort of if the organization wants something to be open, we're happy to work with them. But it's something that's sort of core to our mission. Really, is that everything needs to be open source and available, transparent as well.
I'm so impressed with this group is just like how interdisciplinary the people involved are. What's it been like working with people that come from so many different areas?
It's really good, and it's really interesting. But you quickly learn that there's no new problems anywhere. So I mean, everyone's had the same problem in a different, maybe a slightly different format, but it's all the same problem. Coming from sort of ecology, environmental studies, we always have this thing of, oh, medicine's amazing, it's got so much data, it's so perfect, and they don't think they've got everything right. And then you quickly learn that that's not true, and things are probably equally messy in different ways to ecology. So it's been really good. But also, what's really exciting is that working with not only coders but practitioners and other researchers, you learn so much about different ways of doing things, and that combination sort of gives new solutions to sort of very common problems, which is quite nice. I enjoy it. This is why I do it. Really, I don't get paid for it, so it's good fun.
Questions?
I have a small question. You say you don't get paid for it, like no one in the ESHackathon gets paid for any of this. They just give their time.
Yeah, so we're trying to get paid for it. So so Neal gets paid for his time during doing the training. We have some core funding. You can tell it's nighttime because the lights keep turning off here. But we have some core funding that is sort of running out quite quickly. So we try to sort of things like for the Newcastle hackathon, for example, my time wasn't paid, but my travel to Newcastle was. Luckily, I can stay at my mum's house, so that saves some money there. So those sort of things. We have just starting to apply for a big lot of money, which would support us for 5 years, and would allow me to do 2 days work on the hackathon, which I mean, at the moment I'm doing, a few hours here and there where I can, and a lot of it's, things take time when you haven't got time to sit down and code, or think about how to do the coding and things. So a lot of it's piecemeal, which is quite frustrating. So if someone has a bug, sometimes it might take Neal and I a few weeks to get to that bug, and then a few more weeks to work out how we solve that bug. So that's the frustrating thing at the moment is we haven't got it properly funded. But I'm really confident with this upcoming bid, but also the future, that we can get some of our time funded at least, and that would make a massive difference to us. Really push things a lot further on. We have hundreds of ideas and very little time, so it's about maybe getting some more time and to put those ideas in practice.
I have a quick question. So you have so many projects you're working on. I just wondering, like, as this has grown, you've gotten involved in more things. How have you kind of managed, your attention on certain projects or maintaining different? I don't know. I feel like as a grad student, I have a little bit much more minor focus than where you're at right now.
Yeah, well, it's one of the skills of being a researcher at NINA, at least where I am, is to be able to do 8,000 things at once. So that's something I can do. But I think it's what we try to do is trying to get one major project finished perhaps every year, or finished as in working. We have some ideas for improving things and making them better, but we're trying to get a usable tool. So in the first year, it was EviAtlas as being a usable tool for people to use. And then we did a bit of extra work on that to improve things like allowing you to add shapefiles as a base map, for example, which happened over the following year. So we did EviAtlas in 3 days, but then it took us a year and a half to do the next stage, which shouldn't have taken that long. Citationchaser was another project we wanted to get finished. And it's at a stage now where it's usable, but there's things we want to fix and make better and make it more pretty. So it's about having maybe not trying to do everything at once, but trying to do something yeah, they have the term sort of like minimal viable product. So something that is usable, but maybe not all the whistles and bells you'd like in it. And that's something we do. So it also, we rely a lot on our members, our collaborators, our group. So if someone has time to do something, then often they might do it. And also if they have time within their workload and they don't mind, working on a tool that we've developed, then that's really useful as well. So there are some unsung heroes in the background doing the hard work.
Hi, Matt. I'm curious if you guys have thought about, you probably have, but I'd just be curious if there's been any discussion around creating a package that contains a variety of visuals, helping you create visuals for your meta-analysis or synthesis output. I know for mine, I had to go to 3 different packages to get all that I wanted. And so I was just kind of curious about that.
Well, we haven't specifically thought about that. So one of the packages that came out of the Canberra hackathon is the orchard plots, which is a useful thing.
I used them.
Cool. So I think maybe that's something we could do for the future. That's probably a good idea for that. So our big vision. So Neal and I have a big vision, which I don't think is ever going to come true. But our big vision is having like the tidyverse for meta-analysis, and it's something we call metaverse. So basically, all the stages of a review or a systematic map, and how those packages sort of would fit in, and you just load up the metaverse, and then all those packages are loaded and ready for you. When we're writing a paper now looking at this concept, and there's sort of so many different packages, most of them meta-analysis packages, to be honest. But there are some gaps in the workflow that we need to sort of cover. But it's something that we're really keen on doing. I don't know whether it would be a massive package, so it might not work in our. But having something conceptually at least where you can say, I need to do this part of the review. Which tool should I use? And go to that tool. So a catalog, maybe.
I'll give it a last call. Get your pints now. Okay, well, then I say we'll call it right there. We do have one more online seminar coming up next month on, let's see, on May 17th with Emma Hart from Teachers College Columbia. She's going to be sharing findings from an empirical meta-analysis. Her title is Investigating Patterns of Fade Out Using MRF, the meta-analysis of educational RCTs with follow-up. So please do join us for that. And thank you once again very much to Matt Grainger for sharing this work with us. It's just really impressive and useful. So thank you very much.
Thank you.